Okay, I wasn't planning on making a video for you guys, but I got my tablet working better because I installed new drivers for it. So everything looks a lot better. So guess what? You're treated to a new video. Hold your applause. Okay. This is, again, kind of like the classic systems of equations problem, but with a twist, because at the end of it, they want you to do a little bit more calculation. But I guess the most relevant part to what we're learning now is the first part of this problem. So it says use any problem-solving strategy to solve the following problem. Altogether, 568 tickets were sold to a play. An adult ticket cost $5 and a child's ticket cost $2. Ticket sales were $2,345. The theater manager expects to sell the same number of tickets to the next play, but wants to increase ticket sales to $3,554 by increasing the price of adult tickets. Find the new price of an adult ticket. Okay, well, we're going to do one thing at a time here. So there's two variables in this problem. The two variables are the number of adult tickets and the number of child's tickets. So first, let's represent those with variables. So we're going to say, I suppose we're going to let A and C equal, hold on one second. Okay, so we're going to let A equal the number of adult tickets, and then we're going to let C equal the number of children's tickets. Okay, so one equation that we can come up with has to do with the total number of tickets. So the total number of tickets is 568, and I guess we're assuming there's only adult and children's tickets. So the number of adult tickets, that's an A, plus the number of children's tickets should equal 568. By the way, please stop and notice how much nicer this looks than it did last week. Thank you. And that's our first equation. We have two variables, so we got to come up with another equation. And the other equation has to do with how much revenue was brought in. They brought in a total of $2,345, and that's comprised of adult tickets for $5 each and children's tickets for $2 each. So they got $5 for every adult ticket. We can write that as 5 times the number of adult tickets, plus they got $2 for every children's ticket, which is 2 times the number of children's tickets, and altogether that's going to equal $2,345. That's nice. However, we have two different equations with two variables, and what we really need to do is to do some kind of substitution where we can get one equation with one variable. So what I'm going to do here is I'm going to subtract C from both sides, and I'm going to get A equals 568 minus C. So if you subtract C over here, that just cancels out. You're left with just A. And then if you subtract C from this side, you have 568 minus C. So then in this equation here, where I see 5A, I know that I can replace A with 568 minus C. And then everything else is going to be the same, plus 2C equals 2345. Okay, well, I got to do some distributing here, and I can't do that in my head, so I'm going to do my calculator. 5 times 568. Okay, so that's 2,840. Well, let's see here. 2,840 minus 5 times negative C is minus 5C, plus 2C equals 2345. This, if we combine like terms, we get 2840 minus 3C equals 2345. That's a 4. Then I'm going to subtract 2840 from both sides. Okay, so this cancels out entirely, and I'm left with negative 3C equals, what is this? Let's see. 2345 $28.45 minus $28.40 equals negative $495. And finally, I want to divide both sides by -3, so I can just take that value and divide it by -3, and we get, what do we get? C equals 165. Okay, are we done? Actually, we're not even close, because first we got to figure out how many adult tickets were sold. These two have to add up to 568, so I can just go over to my calculator and do 568 minus 165. So then the number of adult tickets is 403. So I guess I'm going to stop the video here, and then when we're in class, we can figure out if this answer is correct, and then how to answer this question here, which is what should the new price of an adult ticket be if we want to bring the total sales up to $35.54.